Hello guys and welcome to a new video in physics. In this video, we will talk about example problem 2. Here we have an example on page 220. The example is, at the conclusion of his competition routine, an ice skater spins in one spot at a rate of 2.5 rotations per second. If you assume that his moment of inertia is 0.50 kilogram meter square, what is his angular momentum? At the conclusion of the spin, the skater slowly and dramatically slows to a stop over 3 seconds by dragging the toe on one skate. What was the value and sign of the angular impulse on the skater, and what average torque did the ice exert on the skater? So as we learned in the beginning, we should write the noun and the unknown from the question. The noun we have here in this question, here we have a 2.5 rotation per second, which is omega inertia. So omega inertia equal to 2.5 rotations per second. If you assume that his moment of inertia is 0.50 kilogram meter square, so I have moment of inertia I equal to 0.50 kilogram meter square. What is the angular momentum? The first unknown in this question is the angular momentum, and its symbol is L initial. At the conclusion of the spin, the skater slowly and dramatically slows to a stop over. So here we have a stop. So because of the stop, we have omega final equal to 0 over 3 seconds. So we have delta t equal to 3 seconds. By dragging the toe on the skate, what was the value and the sign of the angular impulse? So this is the second unknown in this question, which is angular impulse. We need to calculate it. What average torque did the ice exert on the skater? So the third unknown in this question is the average torque. I need to find the average torque from this question. Just a note here, because we have in the noun, we have omega final equal to 0, so that means L final equal to 0 also. Because L final, that's equal to omega final multiplied by the moment of inertia, so that will be 0. In the beginning, we will find L initial, which is the angular momentum. We have a law which is L initial equal to I omega initial, which is the moment of inertia multiplied by the angular velocity. So that's equal to I, we have it from the question, which is 0.5 multiplied by the omega inertia, we have it, which is 2.5. But here we have the unit rotations, so to convert the rotations to the right, we should multiply the number by 2 pi. The final result will be 7.9 kilogram meter square over second. And this is the first unknown in this question. The second one, I should find the angular impulse from this question. What's the angular impulse? We have a law which is torque average delta t equal to L final minus L initial. In previous lecture, we said that the left side of this equation that represents the angular impulse. So I can write this equation as this. If we remove this, so our equation will be angular impulse equal to L final minus L initial. This is the same. So angular impulse equal to L final. We said that L final equal to 0 because I have omega final equal to 0. So this is 0 minus L initial. I have the L initial here, which is 7.9. So the final result will be minus 7.9 kilogram meter square over second. And this is the second unknown in this question. The third unknown, I should calculate torque average from this question. So from the general equation, I have it, which is torque average multiplied by delta t equal to L final minus L initial. So I need to find the torque. So by multiplying the two sides by delta t, so that will be equal to torque average equal to L final minus L initial over delta t. L final we have it, which is 0, and L initial we calculated, which is 7.9. Over delta t we have it in the question, which is 3. By using the calculator, the final result will be minus 2.6 Newton meter. This is the unit of the torque. And this is the third unknown in this question, which is the torque. Until here, we reach to the end of the example. Now we will find the question number 6 from the practice problems. So here we have 0.25 meter diameter circular saw blade rotates at 5 times 10 to power 3 RPM. RPM, that represent rotation per minute, as shown in figure 7. This is figure 7. The saw is turned off and takes several seconds for to slow to a complete stop. The moment of inertia of the blade is 8 times 10 to power minus 3 kilogram meter square. Friction in the axle provides an average torque of 2.3 times 10 to power minus 1 Newton meter to slow the blade. How many seconds does it take for the blade to stop? So, as we learned in the beginning, we will write the noun and the unknown from this question. So I will solve it here. Here I have question number 6. In the beginning, I will write the noun. What I have noun in this question. And here we have the unknown. Unknown from the question number 6. So the noun here we have in the beginning a diameter. So we have the diameter that's equal to 0.25 meter. Rotates at 5 times 10 to power 3 RPM. So I have omega inertia, which is equal to 5 times 10 to power 3 RPM. The saw is turned off and takes several seconds for to slow to complete stop. Because we have here a stop, so the omega final, that's equal to 0. The moment of inertia in the blade is 8 times 10 to power minus 3. The moment of inertia, which is I, equal to 8 times 10 to power minus 3 kilogram meter square. The average torque, here we have the average torque, so that's torque equal to 2.3 times 10 to power minus 1 Newton meter to slow the blade. How many seconds does it take for the blade? So I need to calculate delta t. How many seconds here? I need to calculate delta t, so I will write it in the unknown here. Delta t, I need to find it. So until here we reach to the end of known and the unknown in this question, and we will find the delta t now. So here we have in the beginning I have the omega inertia, and the units are pm, so I should convert the unit to rad per second. So in the beginning, this is the solution. Omega inertia equal to 5 times 10 to power 3. I will convert it to rad per second, so I should multiply it by 2 times 3.14, this is the pi, and over 60 to convert the minute to the second. So the result will be this is omega inertia equal to 0.523 by using the calculator multiplied by 10 to power 3. This is rad per second. Now we can find the delta t from the general equation, which is torque delta t. Sorry, here we have delta equal to L final minus L initial. I need to calculate delta t, so delta t equal to, here we have the torque, and here we should write L final minus L initial. Now I will write the numbers, which is delta t equal to L final, I have it, which is 0 minus L initial, which is the omega. Here I have the omega 523 times 10 to power 3 multiplied by 8, which is the moment of inertia, 8 times 10 to power minus 3. Over the torque, I have the torque in this question, which is 2.3 times 10 to power minus 1. And the final result in the delta t, by using the calculator, it should be 18 seconds. Until here we reached to the end of our video. See you soon, inshallah, in another one.